Hi, also here's another kinematic guess method for you. First time I read it, I'm not going to use any of the numbers. I'm just going to say a dump truck filled with sand is moving when it begins to accelerate at a constant rate. After traveling some distance, the truck's speed is different. What is the magnitude of the truck's acceleration? So now I'm going to start looking at numbers. 1.8, and that's meters per second, and it's the beginning of the story, so it's an initial velocity, 1.8 meters per second. After traveling 4.0 times 10 to the second meters, that's a delta x, it's a displacement, and it's 400, but with 2 sig figs, so that's 400 meters. Because of those 2 sig figs, I'm just going to try to remember that that's 2 sig figs for my answer. Now its final speed is going to be Vf. That's 24.0 meters per second. Right, I see that there in the last line. My unknown is the magnitude of the truck's acceleration, so it's going to be A equals question mark, and I'm going to leave it as a question mark. Now I've got to choose my equation, hardest part, but don't worry, we go over to our equation sheet. I know it's going to be one of these kinematics because that's the section we're pulling from right now. That's where I'm going to focus my attention. Not sure which one? That's okay. We can go into the resources, or excuse me, into the week 3, which kinematic to use. There's a decision-making chart right there for you. We'll take a look at this and we'll see what has Vf, Vi, delta x, and A, but leaves out delta t. So that's going to be that last equation there. So that's the 4th kinematic. We copy that over onto our equation sheet. Vf squared equals Vi squared plus 2A delta x. And now we can substitute and solve. Actually, we could do a little rearranging to isolate for A. So we're going to bring the Vi squared over. So we'll have A equals Vf squared minus Vi squared over. And then the 2 and delta x have to be divided through, so 2 delta x. Now we can substitute and solve. The acceleration equals Vf squared, so that's 24 meters per second squared, minus our initial velocity is 1.8 meters per second, and that's going to be squared, divided by 2 as a constant, and delta x in this case is 400 meters. So you have to square those values first and then subtract them, right? Please excuse my dear Aunt Sally. So we get 572.76, and that's going to be meters squared per second squared over 800 meters. One set of meters will be canceled out, so we do our division. And our answer is going to be 0.71595 meters per second squared. Well, we want to make that fancy for the dancy. So we've got 2 sig figs, 2 sig figs, and 3 sig figs. So we're going to keep 2 sig figs, and the third is going to round the second. So we have acceleration equals 0.72 meters per second squared. We're going to box that in. That's the problem.